All right, the next term we want to talk about is a gradient. So a gradient has, first of all, notation for this gradient. You can either use this upside down delta, or you can just write grad f for gradient of f. So this again will involve partial derivatives. To determine what this gradient is, you take the partials and evaluate at the values. So you can just find the partial with respect to x. You multiply by your I, that'll be your I component, and you take it with respect to y for the j. And if you've got 3, it's the same. It's the derivative with respect to x for I, respect to y for j, and respect to z for the k. Okay, so this question here, we just need to find the gradients. Find the gradients of this. We've got 3 variables here, so we need the 3 partials. We need f of f with respect to x. Derivative of f with respect to x, well, we get a y. That middle term goes away, and then we're left with a z. So y plus z is our derivative with respect to x. With respect to y, we get an x, a z, and the third one goes away. And finally, the derivative with respect to z, there's nothing in the first one, but we're left with a y plus x there. So that means that we have the gradients of our function. We're going to have y plus z there. Times the I. X plus z j. And then finally y plus x k. So that's what we have if we want to evaluate that at 1, 2, 3. So our gradients of f evaluated at the point 1, 2, 3. Well, we just plug those in. So we have a 2 and a 3. And then we have a 1 and a 3. And finally a 2 and a 1. Well, that should be a plus. All right, work that time. So ultimately that equals 5i plus 4j plus 3k, and that's what you have.